Good day, grade 12s. I hope you are all well. Today, I want us to look at quadratic sequences and more difficult exam questions. But first, I want us to do a summary of what we have done so far and just very importantly, look at the differences between an arithmetic series and a quadratic series. Because there are instances where we use the same symbol, but it doesn't mean the same. So let's have a look. Okay, so there we are. Okay, so on top of your page, in the front of your exercise book, you write 23 January quadratic sequences, and we look at a summary of what we have done so far and the differences between the two. So for an arithmetic sequence, first term is A, second term A plus D, A plus 2D, A plus 3D, with the difference is D, and we call it the first differences. So the property of an arithmetic sequence is the first differences are the same. And how do we prove an arithmetic sequence? T to prove that T3 minus T2 equals T2 minus T1. If we look at the quadratic sequence, term 1, we know from yesterday, the first term is A plus B plus C. Then we've got these terms here, which you don't need to know the formulas. The first differences, this first one here, the ones in circles, these formulas you need to know. So the first differences, the first term in the first differences is 3A plus B, 5A plus B, 7A plus B. Now they have given questions in the past where they give you the third one. Then you must use 7A plus B and not 3A plus B. But more commonly, they would ask this one here. Okay, now, what is important here to note is, if we take the differences here, the differences are all 2A. So, if we look at the sequence of the first differences, so we just look at this one. Can you see this one forms an arithmetic sequence with a common difference of 2A in each case? Now, this is really important because they use this a lot. So they can ask you now, what is the first difference between term T20 and T30, or 229 and T30, something like that. But you have to know these formulas. Just remember the first three. But the thing is here then that this is not a quadratic sequence, it is a arithmetic sequence. So these ones here we call the first differences. These ones here we call the second differences. So the property of a quadratic sequence is then that the second differences are the same. How do we prove a quadratic sequence? We say we draw this tree, and show that the second differences are the same. Of course, using the values, not the symbols, using the values that they give us. Okay, so to prove arithmetic sequences, we take the terms and we minus them from each other. To prove that the sequence is quadratic, we are going to draw the tree and only that. You don't have to say anything more than that. Now, something really important here is when we look at the arithmetic sequence, the general term is a plus b n minus 1. And the first term, term 1, is a. If we look at the general term for a quadratic sequence, the formula is an squared plus bn plus c. Now the a here is not the first term. The first term in a quadratic sequence is a plus b plus c. So that is really important that you don't get confused by these variables that we use. Okay, so just a quick example. There are different ways of finding the A and the B and the C for quadratic sequences. Some people use simultaneous equations to solve it, but I know with simultaneous equations, a lot of people, it's very easy to make a mistake there. So I would suggest this method. So let's have a look. They give us a sequence. They don't tell us what sequence it is. And they ask for the general term. So first, for us to look at what the sequence is, we have to do the tree. So we first start with the sequence, then the first differences, and then the second differences. Then we see the second differences are the same, and that means our general formula is an squared plus bn plus c. Okay, so I say again, we first write down the sequence. We get the first differences. We see the first differences are not the same. So now we know it's not an arithmetic sequence. We look at the second differences. If they are the same, then it's a quadratic sequence. What happens if these second differences are not the same? Then we go to the third differences. And if they are the same, then we have a cubic sequence. So there are three differences, and the third differences are the same. Then we have a cubic sequence. Now, from our theory, we know that. So to solve the A and the B and the C, we start at the bottom. So we say 2A equals 6 that we know, and then we can work out the A. The second one we do is 3A plus B, and from that one, we can work out the B. 3A plus B, we substitute A, and we get B. And then we say A plus B plus C equals 8. And from that then, sorry, let me just fix this. From that then, we can find out A plus B plus C is 8. We can work out the C. And now my general term is an squared plus bn plus c. And we substitute the A and the B and the C. Okay, so that would be our general term. Then the 20th term of the sequence. So we are just going to take our general term and substitute 20. So let's have a look. That's what we're going to do. Substitute the n with 20, 3n squared plus 3n plus 2, and our T20 is 1262. What is really important here is you can stop here. You don't have to write the 20th term is 1262. but you have to show substitution before you give an answer. So very important here, you have to give substitution and you have to give the answer. Okay, now the questions are going to be more difficult. So let's have a look here. How many terms does the sequence have? How many terms does the sequence have? So we've got 820, 38, 62, and then a lot of terms in between, and then the last term is 1520. So that means we need to find term 1, term 2, term 3, term 4. We need to find the end of the last term. Then we know how many terms the sequence has. But to do this now, we are going to have to solve a quadratic formula. So we are going to say the 1520 of the quadratic sequence is equal to the general formula. Then to solve the n, we are going to say 0 equals. So every time we want to solve n squared or n to the power of 3 or n to the power of 4, we have to say 0 equals. And this is what we get. We factorize with 3, and then we can do the factors. N is equal to minus 23, n equals to 22, and then we know that n has to be positive because we start counting at term 1, term 2, term 3. We can't have a term minus 1. So we write at the minus 23, non-applicable, and n is 22, and that you can stop there. That is your answer. N is 22. So how many terms are there in the sequence? 22. I want us to do a number D as well so that we can do this solving of n once more. So let's have a look at this. If they say which term is equal to 272. So 272 equals the general equation. And then because it's n squared, we have to say 0 equals. So the 272 gets subtracted on both sides. We factorize with 3. Factorize there, the trinomial. So n is equal to minus 10 and 9. And minus 10 is then non-applicable, and our answer is T9 will be equal to 272. The second example. This is what they give us. T1, T2 is 1, T3 minus 6, T5 minus 14. It is given that it's a quadratic sequence. Tn equals an squared plus bn plus c. Determine the second difference of the sequence. Okay, the second difference. So we are going to do this. We're first going to write the sequence, and we are going to use variables for the terms that we do not know. We were given term 2, we were given term 3, we were given term 5. So the two terms that we don't know the value of, we give the name as x and y. The first difference is this. 1 minus x This one, minus 6 minus 1, y minus 6 minus 14 minus 11. And from this now, the second difference, it's minus 7 minus bracket 1 minus x, y plus 6 minus 7 minus 14 minus y minus bracket y plus 6. So these are the three second differences that that the whole tree works out to. Now the question is, what is the values of the second difference, or what is the second difference? Now we are going to use this one and this one because we want to solve, we can solve the y or we can solve the x, but the y has two expressions, so that means they are equal. So we use the y. So we say minus 2y, this one, is equal to y plus 13. And we solve it and we say y is equal to minus 11. So that means your second difference, one of these, will be, you can take any one of them, y plus 13 minus 11 plus 13. So the second differences would be all 2. So those, the value of those ones will all be 2. Equals to 2. The second question is hence. Hence, determine the first term. This one here in the cloud here says, hence means. Use the result from the previous question. That is what hence means. Use the result from the previous question. So the result of the previous question, that's also a tip of how to work it out. So from the previous question, we know that the second differences are equal to 2. So now let's look at our tree again. For our tree, x is the one that they want. They want the first term. And here in our second differences, there is an x. And we know that the whole of the second difference is equal to 2. So we are just going to substitute. And we are going to say the second differences are equal to 2. That means minus 8 plus x is 2. Then x is 10. And we saw here that the x is the first term. So term 1 is equal to 10. And that is then the examples. It is important to watch the video lessons because the video lessons, we are not really at the end of the day going to do those questions that I do in the examples. So in the examples that I give you on the videos, I give you the questions that I think will be in the exam, or it is a question that will make clear to you how a subject works, or a topic works. Okay, I'll see you again. Enjoy the homework. There's homework on the Google Classroom.